Hello again, and welcome to our video for DMA 20 Section 12, our unit on circles. Now for Section 12 and Section 13, the faculty at CCCC has decided to remove some of the topics that are covered in your book and your text. You'll notice that in WebAssign you have condensed assignments for these sections instead of having a learning lab quiz. You'll just have one combined assignment for sections 12 and 13 because we're just covering the highlights from these two sections. So this video will be a little shorter than some of the others. And note that not all topics covered in your textbook are copied in this video and in your assignments for these sections. In this video, we're going to cover some definitions and formulas. Some of these formulas you'll have to memorize, and some of them will be provided for you on your exam. Then we're going to jump into some example problems, and then wrap up with an application problem. Let's start out with some definitions, and we're going to use the circle diagram over here to the right as reference as we talk about these formulas. Now, these first definitions and formulas over here on the left are things that won't be provided for you on your test. But down here, you will have a formula sheet for your quizzes and your final exam, and you'll be given these three formulas here. So you don't have to memorize these, but you do need to know what all these different components are and how to apply them. So first, let's start off with these terms up here. The letter D in these formulas stands for the diameter. And the diameter is the length from edge to edge running through the center of your circle. So it starts on one edge, it passes through the center, and ends at the other edge. That's the diameter. The radius is just from the center to the edge. So this line here, okay? That's a radius. It goes from the center to the edge of the circle, and we can think of the radius as the diameter divided by 2. If you look at this diameter here, this line would be a radius, and this line would be a radius. So the diameter divided in half is going to give you 1 radius. And that's important when we work with the area of a circle, which we'll talk about in a little bit. If you're given the radius and you need to find the diameter, we can multiply the radius by 2 to find out what that diameter is. And then lastly, we have this Greek letter called pi, and that's spelled P-I. And pi, when we're dealing with geometry, is a known ratio. It's a non-terminating decimal, which means it goes on forever, but we're going to approximate it to 3.14. This has been calculated to millions and billions and trillions of digits. The number never ends, and it never repeats. It's a really interesting ratio. But for our purposes, we can just approximate pi to 3.14. So whenever we see this constant pi in these formulas below, we're just going to use that approximation 3.14 to get approximate answers for the area and the circumference of our circles. Now, these down here are the areas or the formulas that will be given to you for your final exam. A here is area, and we know that area is the inside of a shape. So if we were to shade a circle in, that would be the area. And C is circumference. And that's going to be the distance around the outside of a circle. So think of it as maybe like the perimeter of a circle, although we don't call it perimeter when we're dealing with circles. We call it circumference because it's round. Okay, so the formula for area equals that constant pi times the radius squared. Circumference, we have two different formulas. If we're given the radius, we can use the formula circumference equals 2 times pi times the radius. Or if we're given the diameter, we can say that the circumference is equal to the constant pi just times the diameter. Remember, when there's no symbols in between these letters, we imagine that there's implied multiplication there. So those are all the formulas and definitions that you're going to need for this section of DMA 20. Now that we have all that down, let's jump right into some examples. So in this first example, we're going to find the exact and the approximate area and circumference of a circle with a radius of 5 inches. So here we're given a radius, so we're going to keep that in mind when we use our formulas. Now exact means we're going to leave pi in the equation, because remember, pi goes on forever. If we want an exact area or circumference, we're going to leave pi in there. And an approximate answer, we're going to use 3.14. Now, WebAssign is going to ask you for each of these when you do some of your homework. So the first blank with the exact, you'll use this Greek letter pi to express your answer. And you'll get that little pop-up window on the side in WebAssign when you click to enter that answer. And there's a button called Symbols. It's not shown here, but I'm just kind of mimicking what's going on in WebAssign. You'll click on Symbols, and then you'll find this letter pi in there. So a good note, a good trick to remember that you're supposed to put pi in there is if you see that box pop up on the side, then you know that you need to include that letter pi. And the approximate answer, space, you won't get that box. So that's how we know we're going to plug in 3.14 and perform the necessary calculations to find out what our approximate answer is. So let's start with area. We know that area equals pi times the radius squared. Okay, and we'll start off by calculating the exact answer. So this is going to be pi times the radius of 5 squared. Okay, 5 squared is 25. So we could say this is pi times 25. And WebAssign will accept that as an appropriate answer. But mathematically, we always want to try and lead with numbers and have letters afterwards if we can. So I might write this as 25 pi. Okay, and that's going to be our exact answer. Now we're going to find the approximate answer of this. And to do that, we're going to do 25 times 3.14. I'll put 3.14 on top and multiply those two. So I'm doing the 25 times pi. So let's start with the 5. 5 times 4 is 20. 5 times 1 is 5, plus 2 is 7, and 5 times 3 is 15. Put in my 0 placeholder and then multiply the 2. I get 8, 2, and 6. Then I'll add these together. 0, 5, regroup the 1, 8, and 7. And I'll move my decimal place in 2 decimal places. So this is 78.5. WebAssign will tell you what place value to approximate your area and your circumference to. So our approximate area would be 78.5, and area is going to be measured in inches squared. We use square units for area. So this is going to be our approximate answer. So we've got exact and approximate answers for the area here. Now give me just one moment. I'm going to clear this up, make a little bit of room, and then we'll do the circumference. Now we'll calculate the circumference, both exact and approximate answers for this. We're going to use that first formula, circumference equals 2 times pi times r, because we're given the radius here. Okay, and we'll start by plugging in our radius. That's going to be 2 times pi times 5. Okay, great, we're almost there. I'm going to move a couple things around because we can do this with multiplication. 2 times 5 times pi. Just so my numbers are next to each other, it's a little easier to see. And then we'll finish with our multiplication. 2 times 5 is 10. So our exact answer will be 10 pi. So now we can do our approximate answer. We use this wavy line to show approximate, and then we're going to do 10 times 3.14. So 3.14 times 10. And if we remember our special rules for multiplying decimals by powers of 10, I just need to move my decimal place one place to the right. So my answer here is going to be 31.4. So my approximate answer is 31.4 inches. No square units with circumference is a linear distance, so 31.4 inches is going to be my approximate answer. Now let's look at another example. And this example, pretty much the same as last time, but here we're given a diameter, okay, of 16 centimeters. We still need to find exact and approximate answers. So let's start with area. Remember, area is equal to pi times r squared. But we don't have a radius here, we have a diameter. So let's remember that the radius is the diameter divided by 2. Or 16 divided by 2 in this case, which is going to give us 8. So whenever we're given a diameter, we have to divide it by 2 or cut it in half to get the radius so we can find the area. We don't have to do that with circumference because of our other formula that we have, but we do need to do that for radius. So now we have pi times 8 squared when we plug in 8 for our radius. And when we square 8, we're going to get 64. And 64 pi is going to be our first answer, our exact answer. And then we can move on to find the approximate answer. We need to do 3.14 times 64, pi times 64, and that'll give us our approximate answer. So we'll start multiplying by 4. We get 16. 4 plus 1 is 5. And then 12. 0 placeholder. 6 times 4 is 24. 6 plus 2 is 8. And 6 times 3 is 18. We add these together. We get 6, 9, 10, 10 again, and 2. And we need to move our decimal over 2 places. So our approximate answer is 200.96 inches squared for the area. So there are both the exact and approximate answers for the area of this circle. Now give me just one moment while I pause and make more room so we can find the circumference again. Alright, now it's time to find the circumference. We could use the 2 pi r formula that we used before, but remember when we have that second formula, circumference equals pi times the diameter. Since we're given the diameter here, that's going to be the easiest way to find the circumference here. It's simply going to be pi times the diameter of 16, or we might write this as 16 pi. And simple as that, we have our exact answer. Now on to the approximation. It's 16 times pi, or 3.14 times 16. And time to multiply. 6 times 4 is 24. 6 times 1 is 6 plus 2 is 8. And then 6 times 3 is 18. Placeholder 0, and then start multiplying by 1. And last but not least, we'll add these two numbers together. And when we move our decimal place in twice, we get 50.24 centimeters as our approximated circumference. Now on to our application example. Here we want to find the, excuse my typo, the area of the shaded region of the shape pictured below. So here we've got a square with a circle cut out inside of it. And the only things that's shaded here is these corners, right? So how are we going to find the area of this? Well, we know how to find the area of the square, right? And what's cut out is a circle, which we can also find the area of. If we find the area of the square and then subtract the area of the circle, all that's going to be left are these tiny corners. So that's exactly what we're going to do. So the area of a square, recall, the area of a square is the side length squared. So our side length here is 8 squared, and 8 squared is going to be 64 inches squared. So that's the total area of the square. And now we need to subtract the area of our circle. The area of our circle is pi r squared. So let's talk about what the radius of this circle is. If we kind of draw the diameter of the circle here, we notice that it's the same as the side length of 8. So our diameter here is 8. If the diameter is 8, then the radius is going to be from the center to the edge, half of that, or 4. So our radius here is going to be 4. So this is going to be pi times 4 squared, or 16 pi. Now, we're going to probably need an approximation of this right now, because we can't really do 64 minus 16 pi. So let's go ahead and find the approximate answer here. So I'm going to do 3.14 times 16. I think we did this earlier. I can't remember. But let's go ahead and do it again for practice. We get 24, 8, 18, and then 0, 4, 1, 3. When I add these together, I get 4, 2, 10, and 5. Moving my decimal in 2 places, I get 50.24 approximately. Okay, and now we need to subtract these two areas to get our leftover area. It's going to be 64 minus 50.24, lining them up at the decimal. I'm going to add extra zeros to 64 to make it the same length so I can subtract. I have to borrow to do the 0 minus 4, so I go all the way over to the 4 to borrow. It becomes a 3. The in-between 0 becomes a 9. And lastly, I get 10. 10 minus 4 is 6. 9 minus 2 is 7. I'm going to bring down that decimal. 3 minus 0 is 3. And 6 minus 5 is 1. So our leftover area is going to be approximately 13.76 inches squared. So that does it for section 12. Here we covered the definitions and formulas of circles that we needed to know for this DMA 20 class. We did some example problems finding the area and circumference of circles when we were given the radius and when we were given a diameter, and then we ended with an application problem. Next up, it's our very last video for DMA 20, section 2.13, scientific notation.